Define electromotive force. What is electromotive force or EMF? It is work done. You have to learn the standard definition. It is work done on unit charge to move around a closed circuit. So how much work done or how much energy is used to move the charge around a closed circuit? Work done by a source or a power supply. When chemical energy changes to electrical energy in a closed circuit, we call that as EMF or electromotive force. Learn the standard definition. I have already shared with you the file, all the definitions. So learn from that. Figure 8.1 shows an EMF 60 volt circuit. So E is 60 volts, 60 V. A 10 ohm resistor is there, X and H, where H is a heater with a resistance of 22.5. So this is 22.5 ohm. And the potential across the resistor is 45. So if the potential is 45, how much voltage will be here? If total is 60, this is 45. How much is this? Because the total 15. And what is the voltage across the 10 ohm? That's also 15 because they are in parallel. When two are in parallel, they will receive the same voltage. The question is the power of the heater. If we need the power of the heater, we have the voltage and we have the resistance. So we can directly, because power is having different formulas. If we have voltage and current, P equals VI. If we have voltage and resistance, V square over R. And if we have current and resistance, I square R. So power is equals to V square over R. So V is 45 square divided by resistance, 22.5. 45 square. So this will be 90 watts. The potential across resistor X. So what will the potential across resistor X? So we did that part, it will be 15. The current in the 10 ohm resistor. So how we work out the current in 10 ohm resistor? As I mentioned, this is 45 volts. So this was 60. So this is 15 volts and this also 15. So we have the resistance and we have, so we use the formula V equals IR. V is a voltage, which is 15. I is a current and R is a resistance 10. So this will be there in division. So 15 divided by 10, the current will be 1.5 and the unit will be ampere. So voltage divided by resistance will give us the current. Another question related to electromagnetic effects. Figure 6.1 shows two bar magnets are there. On figure 6.1, sketch the pattern and the direction of the magnetic field lines. How the magnetic field lines will appear. So from north to south, and it should be equally spaced in exam when you draw, because between the magnetic poles, there's a constant magnetic field. So in between them, there should be straight line, equally spaced. Around, it should be curved. Figure 6.2 shows a bar magnet with a coil. So this is a AC generator because slip rings are there, a galvanometer. The coil of a wire is rotated in the direction as shown, as you can see in the direction. On the figure, draw an arrow to show the direction of the current. First, which rule we'll use, right or left? Right hand, because it's a AC generator or induced current, so we'll use a right hand. When we use a right hand rule, for AC generators, because slip rings are there, so we use a right hand. So your index finger or your first finger represent the magnetic field, which is from north to south. So your index finger is pointing towards the right hand side. Your thumb shows the motion of the wire. So what is the motion of the wire? Which direction any side you can take, like example, you called A, B, C, D. So which direction AB will move? AB will move up. And which direction CD is moving? It is moving down. So what is the direction? You have to use a right hand rule. Your index finger point towards south. So when you use the rule, your index finger will point towards the south, which is toward the right hand side. Your thumb point in the direction of the motion of the wire for side AB, it's upward. So finger is pointing into, it means the direction of the current for AB, it is into. Means the direction of a current from A to B. And same way when you apply the rule from other side for CD or DC, it will be out. So this will be the direction of the current. Clear? Is it clear, this part? Then the explanation why the coil rotated in the direction, or draw and explain your answer like the points you can see here for part B2. So the field direction, like the magnetic field and the motion, they are all perpendicular. So as a result, it will produce EMF. And we use the right hand rule. Explain how rotating the coil in figure 6.2 continuously cause the galvanometer needle to deflect, needle to show an alternating current. So what will happen when we rotate the wire? There will be a change in magnetic field. And this change in magnetic field will induce EMF. When the coil is horizontal, we'll have the maximum induced EMF. When it is vertical, we'll have the minimum induced EMF. And the direction of induced EMF will change as the coil will rotate 180-degree rotation or every half rotation. The slip rings are there, continuous contact it provides. Like the points here, first thing, as a coil rotate, it cuts the magnetic field between the magnet. Or you can say there will be a change in the magnetic field or change in magnetic flux. This induce EMF, that is the second point. And this produce a current, and which is transferred to the galvanometer by the slip rings and the carbon brushes, and direction of the current flow changes after every 180-degree rotation. So the points, the coil is rotating. This is also a working of AC generator. The coil is rotating. There is a change in the magnetic field. Change in magnetic field induce EMF. And induce EMF, the direction of induced EMF changes after every 180-degree rotation. And the current which is produced transferred by using the slip rings, carbon brushes to the galvanometer. And mention that point also, because usually this question, they give the mark for the points that when the coil is horizontal, the induced EMF is maximum. And when the coil is vertical, the induced EMF is minimum. The next is figure 7.1, shows a 12-volt battery and two identical lamps and a resistor Q is there. A 12-volt battery consists of cells connected in series. The total one is 1.5. How many cells are there to make 12? So 8 multiplied by 1.5, that will make 12. When the switch is closed, the ammeter reads 2.4. Calculate the total resistance. So how to work out the total resistance? The total voltage of a battery is 12, the cell combination of the cell, and the total current in the circuit is 2.4. How to get the total resistance? Again, use the formula V equals IR. So V 2.4 divided by 12 12 divided by 2.4. So 12 divided by 2.4 will give us the resistance. What's the answer? 5 ohms. So the total circuit resistance is 5. Each lamp has a resistance of 3. Calculate the resistance of Q. So each lamp is having a resistance of 3. This is 3 ohm. This is 3 ohm. And the total resistance of this circuit is what? 5 ohm, the combined. So example, if we say this resistance is X, first, what is the combined resistance of two lamps connected in parallel? So it will be product divided by sum. So 3 multiplied by 3 plus 3 plus 3. So it will be 9 divided by 6, which is 1.5 ohm. So 1.5 ohm is a combined resistance of the two lamps. And this 1.5, like this combined 1.5 plus X, which is a resistance of Q, the total is equals to 5. So this 1.5 move other side, so X is equals to 3.5 ohm. Then on a figure 7.1, draw a symbol for a voltmeter to measure the potential across the two lamps. So if you want to measure how we connect a voltmeter, so in parallel, so we can connect either above or below, like anywhere we can connect. How we know the total, this was a part, the total resistance of the circuit, that was V divided by I, that was R. So voltage was 12 and 2.4, that's why the total resistance was 5. Then calculate the power supplied to one lamp. So we have resistances there. Because these are the identical lamps. If these two are identical lamps, this current was 2.4. So if identical lamps, like the total current enter was 2.4 ampere, which will divide in the branches. So this will be 1.2 ampere. This will also be 1.2 ampere. And the resistance of each lamp is 3. So if you need the power, P is equals to, because we have the current and the resistance, so P is I square R. So 1.2 square multiplied by resistance, which is 3. This will give us the total power. Each lamp is having a resistance of 3, I think. So it will be 4.32 volt. That's the power of one lamp.